Good morning, everyone. Welcome to the third and the final part of class and objects using C++. And if you recall from our previous video, from part 2, that we have discussed about constructors and array of object initialization and many other topics. So, and this final part of this object class and object has been discussed for all the remaining things like constant object, static member function, static members, and friend function, friend class. Okay, so let us begin with the constant object, which we have just seen before in the part 2, in the last part of the part 2, which is used as a constant object is used and passed as a argument to the copy constructor, if you remember. So let us see what is the other actually the use of constant keyword. So constant object, the constant keyword, its task remains the same. So but when it comes to a constant object, then when we make a constant object or constant variable, it must be initialized and remain as it was. So once a constant class object has been initialized, okay, via some construct or something, then we are not allowed to modify that object anymore. Means those values are generally initialized via constructors. So whatever has been initialized, that is their final, that is a constant. Okay, so all data members values will remain. It's like a object with fixed values, we can say an object with the fixed values. Any attempt you will make to change any of the data member by using some member function or directly will get an error. So that is the objective constant. Constant objects are mostly used just like they are meant for using some standard objects, standard value objects. Say for example, we are using some objects of various let's say various equipments. Okay, so we can define a constant object which will keep the standard value of the document. Okay, let's say equipment's length should be this, length should be this. So the general objects which are may vary with some slightly size. We can cross check that, okay, is it within the range of within the value of the standard object or not. So defining standard values, okay, and fixing, because the standard values are not going to change, then for those purpose we can use the constant objects. That is the main idea. So remember, once a constant class object is initialized, so generally we see an example here. So we will just append the constant keyword before the declaration, okay, of an object. So constant distance object 3, this indicates that this object 3 is initialized via default constructor. It is very clear that when we declare an object like this, it is going to initialize via default constructor. So it's up to you how you initialize the object, through a copy constructor or through a parameterized constructor or default constructor. So but once the member values of these objects are initialized, they are going to be fixed, and any attempt to make changes to these values will give an error. So it's that is the idea of constant object. Similarly, we can define constant member function. Okay, so when we say a constant object can only call a constant member function. Okay, because the constant member function job is to that do not make any changes of any class variable or call any non-constant member function. Okay, so the two things to be remembered here. So why? Because we know that the constant object's member cannot be modified. So it is always safe to call a constant member function, okay, with reference to a constant object. So a constant member function actually they guarantee that it will not change any class variable or call any non-constant member. So again, if you try to make an attempt to call a non-constant member function from a constant member function, that will give an error. So to make a function constant member function, we'll simply append the constant keyword, just like we have done. Not just like the data. We will just append after the function definition, not like the declaration. In declaration, we just put it before it. We prefix here. And in here we'll use a suffix kind of thing. Okay, we'll append at the end. Okay, so you can see the example right here. So void show distance function here is made constant. That means it is not allowed to member function is not allowed to make any changes to any variable. That means suppose we are defining some member function which can only do some display kind of work, okay, or referring or accessing. The job is to only access. So to ensure that it accidentally doesn't modify any data member, especially member function, then we can make it constant member function. Okay, that's the idea. So any constant member function that attempt to change a member variable or call a constant member function will cause error. This you should remember. Okay. Then comes to static member function. I think static keyword, all of you are already know about this keyword in C, okay, and also in C++ we discuss about static member. So I think same kind of definition is right here. Only thing we have to use it in a different way. So static member of a class are, and you can say once they are data member means they are attribute, but they are part of class. They are no more a part of an object. When we define a data member, so every object will have their own copy of the data member, own value. Let's say name, right? So a student 1 has name, let's say XYZ. Student 2 has name, let's say PQR. Okay. So every student object will have a value for that data member, which is normal for a non-static data member. When it comes to static data member, let's say for a student class, I define a static member called strength. So strength will not be a data member, will not have any value for a particular object. So mean to say that student number 1 cannot have the value for strength. Student 2 cannot have. So overall, all the entire class of student will have a data member strength. And yes, all the objects, they can refer this value, that what is the strength, what is the strength value of this class. Okay, so they can refer it, but it will not be a individual copy for each object. In other words, we can say there is exactly one copy of static member instead of one copy per object. Okay, so a function that needs to access to members of a class yet does not need to be invoked for a particular object is called static member function. So suppose we define a function which need to access the member of the class and which can be invoked, but while invoking it, there is no restriction that it need to be invoked, it need to be called with reference to an object. What we have seen so far, the all member function, any member function of a class need to be invoked via an object or with reference to an object. But there is this restriction is relaxed for static member function. When a function member is a static member function, then it may be called via an object, but it may not be called, because static member functions are allowed to operate only on the static data members. They cannot access non-static data members. Okay, that is the restriction in the static member function. So the common use of static is to define class constant. Means suppose you are defining a particular class, each class will have some constant values. Maybe it's related to mathematics or related to management and any topic. We take any application for that purpose. We define constants which are common mostly. So for that we maybe constant doesn't mean that that value is fixed. Okay, then we can make a constant keyword. But the values which are common, which are a common value, a common data is stored for a particular class, not for individual objects. Okay, as I told you, the example is strength. All right. So to make a field static, add the static keyword in front of the field. So if you want to make a data member as a static, so use the static keyword in front of that. You want to make a member function static, okay, then you have to use the static keyword exactly in the beginning of the member function definition, unlike the constant keyword. Okay, so static class member, some more information. So static data members are accessible by both static and non-static member function, but a static member function can access only static class members. Means a non-static class member has flexibility that it can refer to non-static members as well as static data members. But the member functions which are static, they have restriction. They can only access static data members, no other members. Okay. So to access a public class member, public static class member, suppose we have declared a static data class member. Okay, we don't say data member because they are, when you say data member, no, we tell it verbally, but mostly it is a member of a class. That's why the term class member, static class member, is more appropriate. What I mentioned in the slide. Okay, we tell it fine, just to understand. So to access a public class member, suppose we have declared a static variable which is in the public part. Okay, then we can refer this, we can access this outside because it's a public, it can be outside the scope anywhere. So when we want to refer to this particular variable, static variable, we use the class name scope with the scope resolution operator to indicate that this is a member of this class. Okay, because we don't need any object to access it. Okay, that's an optional, we can use or without, but we can refer by class name. Okay, so to access a private static class member, suppose we have made private when no object exists to take help of static member function. Okay, otherwise non-static could be used. I mean to say that when we have private static class members, only generally via static member function we access them, we operate on them via static member function. Suppose we don't have any static member functions, then we can take help of non-static member function, unless we don't have that. Okay, but in the if they are private, they cannot be accessed directly outside the scope of the class. That's for sure. So first example, okay, so we can see I'm taking the class of employee. I have a name, string with the name string. Then I have a private static member, that is a static int count. So count is a copy for the entire class now. Okay, it's a common variable that can be accessed by every object. We can say every object can share this value. Okay, indirectly they are sharing this value. All right, so they can update it. So we have three methods: get name, get count, and static void in count. So there are two among these. One member function is non-static, that is get name, but get count and increment count both are static member function. That means they are allowed to operate only on the one data member, that is count. They cannot access name. They are not allowed to access the name. Now next come to global declaration of a static variable, global initialization, not in declaration and initialization. Actually, whenever we have a static data member, okay, when the class is loaded, it needs to be initialized, because it will not be initialized by any constructor. We can we can change the values by using static member function. We can manipulate, but need to be initialized. So initialization is generally done at the global scope level, like this. Okay, so when the program is loaded, okay, that value is initialized, that static value is initialized, and that value then later on it can be accessed by any data member or any data member static member function, or any object, through any object we can do that. Okay, so see that we have, so it get count will simply return the count, and increment count will simply increment the count value. And okay, so by this what happens, when we start our program, the count value, the count of this employee class is 0, right? So then we have created a new employee, let's say E1 by through dynamic memory allocation. Okay, using name is Bob. We are passing the name as Bob. Okay, you can see that. So assume that we have a parameter constructor. I'm not defined here. Okay, assume that we have that, so we can do using this particular statement, employee star equal E1 equal to new employee Bob, means it is a parameterized constructor, definitely. Okay, so dynamically we are passing Bob, so Bob will be the name of the employee. So what, okay, so then E1, okay, increment count, it's a static member function, you see that. Okay, we can still call a static member function using an object, as I told you. This with calling with reference to an object, here it's a pointer to an object. So calling through this is also possible. Only thing is that this part is optional. I may call through an object or a pointer through an object, or I may not call. That is an optional part. Okay, so increment count, so incrementing the count value once an employee is added. Next, another employee is created, so we increment the count, so that when we print this one here using the get count, okay, the starting member function get count will get the updated value of the count, that is 2. Okay, let's see a complete example here, that employee. So we have name, count, and now we have added that whatever you are looking for, that is parameterized constructor. All right, so the job of this parameter constructor is to dynamically allocate memory exactly of length of the string that is passed as a parameter and copy that string to the name. Okay, so when we say Bob, so a new object is created dynamically and the name is assigned as Bob, okay, and John, right? So then also we have destructor to remove the safely remove the deallocate the memory whenever the object is destroyed. Okay, I think other parts remain the same. All right, remain the same. We can see that. So what we do here, we created two objects back to back here, right? We do created it back to here. Initially we print the count, definitely should be 0 because initially it is only initialized at this point and 0. Then two objects created here, one with the Bob, one with the John. Then number of employees. Okay, so so there is a hyphen again, small silly mistakes, sorry for that. Okay, so you can see that what will happen, this value will be 2. Why? Because along with whenever we are creating an object via parameter constructor, we are incrementing the count. And again, don't go by the case sensitivity here, because the count should be small here. It doesn't matter actually, but just to avoid any confusion, I'm drawing back. Okay, so yes, what happens? So but whenever an employee is created, we automatically increment the count within the constructor itself. So what happens when you print here get count, we are going to get 2, right? Then we can take help of the objects to print the names, right? So see here, so we are using the object to call here. It is completely safe and can be done. Similarly, when we delete U1, one employee is destroyed. Okay, so automatically one object is destroyed, so the count will be decremented. So when inside destructor we are decrementing the employee whenever an object is destroyed, right? So here we'll get 1. Then delete E2 will get 0. So 2 are created and 2 are destroyed. Then you see the last line. Last line I am using the other way. I am not taking help of any objects here. That this can be done, but also this any member function, any static member function can be called with referring to and without any object. So here I am calling through the scope resolution operator of the class. So employee colon get count indicate that I am calling the static member function here via the class name. Okay, then here it will print it the count value. Alright, so there are two ways. Any static member can be called via object or may not be, or by directly calling through the scope. You have to mention the scope. When you are mentioning object, it is not required at all, because we know that it can easily understand we are looking for a member function of this particular type of class. Alright, but here whenever we need to call directly, okay, by the name, we need to mention the scope resolution operator. Similarly, imagine that I have made this count public. Then I can access the count directly inside main scope by exactly the same way. Employee, scope resolution operator, count. Okay, in this way I can operate on the static members whenever I need. Okay, so let's see a demonstration of this example. It will be very clear. So we have that particular example with the static. Yes, we have. So VIS static. Let me increase the font a little bit. Okay, that's fine. So this is our full example of the employee class where the static member count is used to keep track of number of objects created, number of objects employees created so far. Okay, so this is a full example. Let us run it. Static. All right, done. output. Initially we print the number of employees, that is 0. When it's initialized, it's 0. Then we created back to back 2 objects, those are, so then the number of employees become 2. Then employee 1, we print the name of the employees, employee 1 Bob, employee 2 John. Then we deleted one employee, so then the number of employees become 1. When delete the second one, it becomes 0. Okay, that's it. So this is how we use the static member and static member function. Okay, next topic, only the final topic is friend keyword. And so we can have friend function, we can have friend classes. So let us understand what is the role of, or what is the importance of friend function. So there could be a situation where we would like 2 classes to share a particular function. Okay, particular function, they say, so find area can be shared by rectangle and triangle, possible, right? So income tax by manager and clerk. So there is some example I'm giving where there is a condition that we may share a common function. C++ allow the common function to be made friendly to both the classes. Okay, so the friendly function is allowed to access to the private data of these classes. So because we have some task which may be needed by more than one class, we know that we can generally perform the task by the member functions, right? So in this case, if the task is nearly same for both the classes, we have to copy and paste, right? You have to make a copy and paste. So to avoid that, okay, the C++ allow to define a function which can be friend to more than one classes, so we can, so what happens when you make a friend somebody, he can come, like, suppose, take an example. I always give this example that, okay, suppose you have a, let's say X has a friend Y. Okay, so what that means, so Y is not a family member. Y is not a family member of the X, but he can come and sit in the house of X, enjoy breakfast, and have fun. They can watch TV, right? So that kind of concept, if you remember like that, okay, this concept can be understood very clearly. Okay, so friend function means a function which is outside of a function. Friend function is not a family member. Okay, it's outsider, but has access to all of our things inside the family. Okay, means private data members. Okay, it can access all the, so it's a function outside a function which have the access to the private data member. Why? Because he is a friend. So we trust on that function that this function will do genuine tasks. Okay, and actually it is violating the encapsulation data hiding policy of object-oriented programming. Okay, it is violating. Friend function is not is generally violating. You will find in the top level other object-oriented programming, they generally avoid this kind of function. Okay, no friend concepts. So this is the idea here. So how we can define friend function? Simply, while declaring a class, we define when declaring class and defining the member functions, we simply add a declaration or a prototype that if the function prototype, and we just append the beginning, that is friend. So it indicates that when I say friend for a class XYZ, when I indicate that friend void friend function, that means friend function is a non-member. It's not a member of the class. That's why he is friend. That's why you are tagging with saying that, okay, he is a friend or she is a friend, kind of thing. Okay, all right. So friend void friend function indicate that friend function is not a member of this class, but allowed to access the private data members outside the class. Because definitely, if it is not a member of the class, it is some outsider, maybe member of other class, may be a global function, a function defined at the global level. That is also possible. So maybe it doesn't matter what is it, okay, but once it becomes a friend of this class, it can access the private data members and also allowed to update it, access and all. So what are the features? It is not in the scope of the class to which it has been declared as a friend. Definitely, it's not in the class, it's somewhere outside. It cannot be called using object reference. It's a non-member function. So it has to be called, if it's a global function defined at a global level, a global level function, then simply you have to call a function with the function name. Or if it is it's a member of other class, it is also possible that if a member of other class, a member function of other class which is friend of this class, so then we have to call with an object of that class. I'll show example of both the classes. Okay, so usually they has an object as argument because they are friend function outsider of this class. Okay, and they are going to operate and are allowed to access the private data member of this class. So generally they accept an argument then object of this class. Okay, and we'll see that often use of this is in the operator overloading, our next session. After this, in the next session, we'll discuss operator overloading. There you will see actually the use of friend function. All right, the first example explain a member function as a friend means a member function of a one class who is friend of other class. Okay, means it is using the value data member of another class. So here the example is a point 2D and circle, right? Two-dimensional point. So first I make a declaration because I using this an object of this inside this class, so I need to be declared here. So I class point 2D declaration that I'm going to define a class somewhere in the scope of my program. So then class circle, center x, center y, then a radius. So okay, then we see that we have a function here void set values. The job of this function is to set the value of all the data member of this class, of this object or class object of this class. Object of this class means every object of the circle will contain a center with a value x and y and radius. And we know that a center is for a circle is a two-dimensional point, right? A two-dimensional coordinate. Okay, so instead of writing like this, I am taking help of a point 2D, okay, to assign the values. Okay, so because when I am assigning the value, I may take a point 2D object to assign the value assign a value of a circle to assign as a center of the circle. Every center of the circle is a two-dimensional point. Okay, so keeping that logic in into the point of view, we when we set the value, when we assign a center and a radius to a particular circle, we assign that center as from a 2D point, right? So we pass the 2D point as an argument. Okay, so when I am passing 2D object which is an object type of class point 2D, I need to access the x coordinate, y coordinate to assign here. So that's why, okay, I have to make this particular function friend of the class point 2D so that it can access the x coordinate, y coordinate of an object of point 2D type. Okay, so then here a point 2D type simply we define, okay, set point, get point, okay, get x value, get y value, that's it. And you see that because we are defining here friend. So yes, this class has a friend. Who is that friend? That friend is the function set value of circle class. So that means he is a member class, a member friend function. Okay, a member friend function. This friend function is a member of the class circle. So friend, this is a return type void. The circle scope resolution operator indicate that this is belongs to the circle class, which is also defined in the global level, in the global scope. Okay, so circle scope set point. So this means indicate that the set value can access the x coordinate, y coordinate of an object which is passed to it. Any object of point 2D that will be passed to set value, it can access them directly. Alright, so let us see what actually set value does. We are defining this function right here after the class definition for clarification. So void circle set value, take a point 2D, that is a p, and integer r for radius. So center x equal to p dot x scope. You see that this function set value is outside the scope of the class point 2D. Okay, but it can access the private data member directly because it's a friend function of this. Alright, so p dot y coordinate, center y equal to p dot y coordinate and radius r. This is the use of friend function. Now here a friend function is a member of other class. We can have a global function, okay, a function which is non-member. A simple function just like in C could be a member also. Sorry, could be a friend also, right? So in the rectangle class we see here, okay, we have width and height, set values, area, we calculate, then friend rectangle duplicate rectangle. So when we want to make a copy of a rectangle object, we are taking help of an outside class. Okay, outside the class to do that. So here we define the member function, set value outside it. Okay, so it's very simple. Here is the function. You see this function, when we say friend rectangle duplicate, so duplicate has no scope. That indicate that this is a non-member function, okay, and defined in the global scope. So rectangle duplicate takes a rectangle object because it accesses the data members. So we create an object, local object, copy all the values and double it. Actually duplicate means it actually duplicating and doubling it. So it creating another object of rectangle which size is double of the current object. Okay, that is the idea. See that. So rect radius dot width equal to rect parameter width star 2. Whatever value we are multiplying with 2, whatever the height we are multiplying by 2, and we return the value wherever in the main function. So here we are calling that function duplicate and passing a rectangle. So because it's a function is defined at the global level and it's not a member of the rectangle, and we have made a friend, that's why it is able to access the private data members directly. Another example where the friend function is not a member of any class. Then comes to friend class. When you found that one class need to use all the member function, or let's say most of the member function are need to access the private data member of other class. Okay, then instead of making each member function as a friend function, better make the entire class as friend. So when we make a class, say for example y, as a friend of the class x, then all the member functions defined inside the class y, okay, has direct access to the private data member of x. Okay, this is the console. I'm repeating it. When we make a class y, okay, as a friend of x, that means all the data member functions of the class y can access the private data members of x directly within their function. Okay, so a simple example here. So class square, then class rectangle, and I'm making the class rectangle as the friend of square. So that means all the member function of the rectangle, they can access the square, all the data member of square directly. So there is only one function I'm defining here, a convert. Okay, also I can do this, but I'm allowed. So any member function defined, they can access directly. It's up to you whether you access or not. So here convert is accessing the data member directly. Okay, so here the entire class is friend of the square, the rectangle is friend of square. Okay, this is the example of friend class. Okay, so that's all. This is the end of discussion of our class and object, and I hope everybody now understood all the concept that has been discussed in this lecture. Thank you for being with us. Okay, and we'll be discussing the next concept, that is object operator overloading, in our next lectures. Thank you very much.